if s is equal to summation k starts from 1 to infinity 1 upon 2 raised to power k plus 1 into tan of pi upon 2 raised to power k plus 1, what is the value of log s with base pi modulus? Let's try to create method of difference technique here. First of all, tan theta minus cot theta is equal to minus 2 cot of 2 theta. This is an identity. Put theta is equal to pi upon 2 raised to power k plus 1 for simplicity. This implies tan of pi upon 2 raised to power k plus 1 minus cot of pi upon 2 raised to power k plus 1 is equal to minus 2 times cot of pi upon 2 raised to power k. From here, tan of pi upon 2 raised to power k plus 1 can be written as cot of pi upon 2 raised to power k plus 1 minus 2 times cot of pi upon 2 raised to power k, taking this term to the right hand side. Therefore, s becomes summation k starts from 1 to infinity 1 upon 2 raised to power k plus 1 into cot of pi upon 2 raised to power k plus 1 minus 2 times cot of pi upon 2 raised to power k. Multiplying this inside the bracket, summation k starts from 1 to infinity 1 upon 2 raised to power k plus 1 into cot of pi upon 2 raised to power k plus 1 minus 2 upon 2 raised to power k plus 1 into cot of pi upon 2 raised to power k. Putting the values of k, we get 1 upon 2 raised to power 2 cot of pi upon 2 raised to power 2 minus 2 upon 2 raised to power 2 into cot of pi upon 2 raised to power 1. Putting k equal to 1. Similarly, on putting k equal to 2, we get 1 upon 2 cube cot of pi upon 2 cube minus 2 upon 2 raised to power cube cot of pi upon 2 square plus, now put k equal to 3, we get 1 upon 2 raised to power 4 cot of pi upon 2 raised to power 4 minus 2 upon 2 raised to power 4 cot of pi upon 2 cube, and this process will go on. And for the nth value, I can write 1 upon 2 raised to power n plus 1 cot of pi upon 2 raised to power n plus 1 minus 2 upon 2 raised to power n plus 1 into cot of pi upon 2 raised to power n, since we know that n tends to infinity, because k was tending towards infinity starting from 1. So first term cancels this term, third term cancels this term, and the pattern will repeat, and this will cancel some term here and some term will cancel this term. So we have only the second last term and the second term. Therefore, s is equal to 1 upon 2 raised to power n plus 1 cot of pi upon 2 raised to power n plus 1 minus 1 upon 2 cot of pi by 2. And since we know limit should tends towards infinity, so s becomes 1 upon 2 raised to power n plus 1 upon tan of pi upon 2 raised to power n plus 1. This cot can be written as 1 upon tangent of pi upon 2 raised to power n plus 1 by using the reciprocal, and this cot will tend towards 0 because cot pi by 2 is 0. Multiply and divided by pi, we get pi upon 2 raised to power n plus 1 whole divided by tangent of pi upon 2 raised to power n plus 1 into 1 upon pi. Now this limit will tend towards 1 because limit when x tends to 0, tan x upon x is equal to 1. So the reciprocal of this limit is also 1, so that's why, because limit n tends to infinity here, s becomes 1 upon pi. Therefore log of s with base pi modulus is equal to log of 1 upon pi with base pi modulus is equal to minus 1 mod, which ultimately becomes 1.